Hello and welcome to another AfterMaths episode of the Primary Maths Podcast, the show where we talk all things primary maths. I'm John Cripwell.
And I'm Becky Brown.
Hello again, Becky. How are you this week?
Hello.
What have you been up to?
Yeah, I'm good, thank you, John. It feels like this is the 76th day of January. It is certainly dragging on, isn't it? But we're nearly there, nearly at the end of the month and into February, and things will start to get a little bit brighter, hopefully, outside. It's been a very rainy week.
Yeah, it has. Very great. We're recording this on Thursday. It goes out on Friday. So yesterday, Wednesday, we had blue skies up here in Derby, and I'd kind of forgotten what those things look like, to be honest, because January has just been dull, hasn't it?
It is so dull, and that blue sky and a bit of sunshine makes all the difference, doesn't it? So yeah, bring on spring. How's your week been?
Yeah, it's been good. It's been busy. I've been out and about, Becky. I've managed to leave the house a couple of times for work. I've been into a lovely school in Derby and saw a great Year 2 lesson, did some work with a teacher there. And then yesterday I was lucky enough to be invited to the LLME conference over in Nottingham, so the local leaders of maths education conference in Nottingham. And that was great. That was really nice just to get to see lots of other people who are all working in the math space and see what people are up to and things. And in fact, I'm going to come back to that story in a couple of minutes when we get into our first topic of today. But yeah, it's been good to be out and about. No conferences or anything this week. No trips to Camden, unfortunately. But nevertheless, yeah, Nottingham's it's not quite the same. But nevertheless, good to get out and see people, see some maths in action.
Good.
So what are we going to talk about this week then, Becky?
So this week we're going to start with a discussion around the differences between doing maths and watching maths and the impact it can have. Then I'm going to share the journey with you that I went on to find out a little bit more about the origins of the calculator. And finally, you have got some hot off the press research into maths anxiety to share with us too.
Yep, which I'll attempt to do in 60 seconds-ish, but as we know, we'll fail miserably. But I still think it's worth spending the extra 10 or 15 seconds or 2 minutes to actually understand what the research is saying. But I will endeavour to get it over as quickly as I can, Becky.
Yeah, good to have a goal.
Yeah, absolutely. So let's get straight on with it then. So doing maths versus watching maths. This is something I have been thinking about for a little while now. So, and in fact, I wrote a LinkedIn post on the subject this morning. So if anybody is on LinkedIn and wants to go and have a look at what I've said about it on there, go and check it out. But essentially, yesterday was a really good example, I think, Becky. So as part of the LLME conference, I was sat on a table with 5 other local leaders of maths education, 5 other teachers, 5 other maths specialists. And as part of the session, we were given some puzzles to have a go at from Alex Bellos's Guardian column, essentially. These have been taken from. And we were basically given 3 puzzles to have a go at, and we weren't told how long we got really, but we had at least half an hour. And I'm okay with maths these days, but some puzzles I find tricky to find a way into immediately, and I think that's part of the fun, isn't it, that people have. So the first one was a little bit of a head scratcher, and we had lots of talk around it and tried some different things, failed. I had a bit of a sulk, threw my pencil down, said it was stupid, got up, had a wander around, got a cup of coffee, talked to a couple of people, suddenly had a realisation out the blue, went back, sat back down again, realised that was the way into the puzzle.
Nice.
Carried on working on it for a couple of minutes, got an answer, was very chuffed with myself, sat back, talked to the person next to me, Lewis, about football for a couple of minutes, had a go at the next one, and so on. And there wasn't, I guess what Pete Mattock would say to me, who is our secondary maths lead here at Twinkle, I guess what he would say to me is that, was there any learning going on? And for me, I think what we were doing was probably exploring learning or knowledge and skills that we already had at this point,
Yeah,
but we were applying them to a totally new context, which I would argue is what maths is really about.
is.
Really, it was problem solving, Becky. I know you love a
Love
bit
it.
of problem solving.
I
Yeah.
do.
Um, but it did make me think, if this was a lesson and somebody was observing it, I think they would say, well, where was the new learning? Where was the pace? Because we spent half an hour probably on these three problems. Um, where was the guided practice? Where was this? Where was that? Um, and I think all of those are sort of valid questions in and of themselves. But what I would argue was that everybody in that room, in one way or another, was totally engaged with the puzzles and with the thinking. And if you looked around the room, and Tom, who's been on this podcast, he was sort of facilitating the session, Tom Isherwood, he was walking around the tables and listening into conversations and things. Because one of the focuses of the day was oracy. Um, and what was really evident was everybody's thinking. You could really hear it in the conversations that were happening. People were trying things, they were failing, they were, coming up with conjectures and trying them and seeing whether they were successful or not. They were spotting things, they were pointing things out to the partner, they were making generalizations. It was all the sorts of skills that you would
Great
want to
stuff.
see and hear exactly in a maths lesson. And I know we were all adults, I know we're all maths specialists, but I don't think that was the point, really. The point was that we'd been given these puzzles, we'd been given opportunity to explore them, and what happened next was a sort of natural consequence of that, really. So it reinforced to me a little bit, clarified my thinking a little bit around this idea of doing maths rather than watching it, because I've seen a lot of lessons over the last 10 years or so where the teacher has probably done more work in the lesson than the pupils have. There's
Yeah.
been lots of short burst work from the pupils and then bring it back together with the teacher and then a little bit more short burst. And I think this has come from that idea of small steps through the lesson, that idea of coherence. But I'm not necessarily sure that small steps always have to be small steps where one step is the child and the next step is the teacher. I think there's opportunity to design a lesson where the children take the small steps themselves through the lesson and there is scaffolding in place to help them to do that. But they get the opportunity to do a lot more of the thinking than perhaps is happening in some classrooms at the moment, Becky. I don't know what you think about that.
Yeah, I mean, it's interesting. I'm thinking about you as the learner. I know we're not talking about maybe tangible learning there, but you as the learner, would it have been so satisfying to you if you hadn't had the time, had that aha moment at the coffee, where you were, you sounded like you were excited by the idea that you actually had your in.
Yeah.
You wouldn't have had that, would you, if someone had stood at the front, maybe called you back a bit earlier or not given you the time and shown you how to do it. So
No,
I think,
and that's the key, isn't it? I think that was probably what would have happened in a lesson. We would have explored it for 5 or 6 minutes, and then we'd have all come back together, and somebody, either the teacher or another pupil, would have explained how to do it. And that's
it's
tempting, isn't it? Because we know that we have a finite resource of time in a lesson, and we want to
yeah,
get to the learning, don't we? We want to make sure that there's progress happening. But there's plenty of research that shows, and I think we've talked about this before, that where you make your own connections and you spot and notice things for yourself, that's a much more concrete and a much more effective form of learning than being told something and remembering it.
yeah. I think as a teacher, it's hard, isn't it? Because you don't want to feel like you're not doing anything. But I mean, you've made a very good point. The people working the hardest in the classroom should be the learners. The teacher should be facilitating that. And that can be hard. It can be hard to think, well, actually, I haven't done anything for 20 minutes. I mean, you have, of course, done lots of things. But if you were talking about Tom going around and chatting. And as a teacher, that is a great tool to have, isn't it? To be able to be part of those discussions rather than standing and teaching from the front. It's
Yeah,
just it's just I think it's probably also making sure that the learners have the toolkit they need. That resilience, I think it comes back to that again, doesn't it? To I mean, you
it
were saying
does. It
you
does.
weren't
But
happy.
I think that's a muscle that you have to train, really, and
Definitely.
that there's no way to impart resilience on somebody
Nope.
without getting them to have a go at things, fail, and then try again.
Yeah.
And I think as well, I needed to throw my pencil down in frustration, call the problem stupid, get up and take a different perspective at it by having a. We don't allow room for that in lessons. We can't. We've got 30 children. We can't have them all getting up and walking around and talking about football and things. That isn't realistic. But we do have to provide time, I think, for failing and trying again, and
Yeah.
not thinking that the failure is a failure of our teaching or a failure of the lesson, but that it's a step towards being able to solve the problem in a longer term.
Yeah, definitely. We talk a lot about learned helplessness, don't we? And if we're always providing the solution in a timely way, people might not feel it was worth spending the time trying to find it out themselves if there's an easy option at the end. And actually, that easy option isn't what you want to do. It doesn't give you
No,
the most joy if you finally get to the answer.
no. So this is what I'm talking about when I'm talking and writing at the moment about watching maths rather than doing maths. I think a lot of lesson structures that we have at the moment spend a lot of time with children watching other children or the teacher doing maths and not enough of it doing not enough time spent doing it themselves. And I do recognize the potential difficulties with the temptation to jump in and help because we're teachers. We want children to be successful, don't we? We want them to have that aha moment. I get it. I can do this. But I think it's a very short-term fix if we're not careful without building long-term progress. So
Yeah.
I'm not sure quite yet exactly what the answer is, but I do think building in time where we can, again, we know time's precious, but building in time where we can in order to give opportunity for exploration and for noticing things and not just pointing things out, that I'm going to be interested. I've got Will McCufflin coming on the podcast in a few weeks' time, actually, to talk about direct instruction in maths. And I have told him I am open to having my mind changed, and maybe I need to learn a little bit more about it. But I'm slightly skeptical about direct instruction as the predominant form of pedagogy in a classroom, just because I think if you start by telling somebody how to do it and then they can't do it, I'm not sure where you go where you go from there. Do you know what I mean? Whereas
Yeah.
at least if they've had a go and then you've got opportunities, haven't you, to sort of to help out in different ways, I think, and scaffold that learning a little bit so that you are pointing them in the right direction.
Yeah. And I think your instruction will probably be more engaging if people have experienced it firsthand first, rather than just having it new, from the
Yeah,
beginning.
yeah.
And I think it comes back a little bit to, and I thought about this when I was listening to your interview with Dominique on Tuesday, it's that skills versus knowledge, isn't it? People look at maths as very much a knowledge. You learn all the facts and then you're a good mathematician. But it's actually the skills, specifically problem solving skills, that are the important bit. It's just less hard to measure the impact and see the impact in as quicker time as the
Did
knowledge bit,
I
I
did
think.
I talk to you, Becky, about Tom Rock's maths and what he said about um
I don't think
so
so.
no, okay. I forget who I've spoken to and who I haven't sometimes, Becky. I apologise. Pete Mattock interviewed Tom Crawford, who is perhaps otherwise better known as Tom Rock's Maths. He is
Yeah.
a maths communicator. I think he got a PhD from Cambridge and now works out of Oxford, or the other way round, one of those two. He's certainly got links with both Cambridge and Oxford as a mathematician, not as a teacher, but as a mathematician. But his role is very much in maths communication and making maths come alive. And Pete interviewed him for our Leading With series of podcasts, which you can find on the Twinkle platform or on YouTube or anywhere else. After you've listened to this, obviously, you need to listen to this first. It's very important. But it was really interesting listening to it, because Tom was saying he sort of first came to the public's attention during lockdown, when he was stuck at home trying to decide how to get his message out about maths. And one thing he decided he thought he would try and do was have a go at a maths GCSE paper and a maths A-level paper, as somebody with a PhD in mathematics, see how he got on. And obviously it wasn't just a video of him sitting in silence for 40 minutes while he had a go at this paper. He talked about how he was approaching the questions and that sort of thing. And he told a little bit of an anecdote. I won't spoil the whole thing, but he told a bit of an anecdote about how one of the first questions was on circles. And he thought, oh no, I haven't, you know, we've talked before, haven't we, about when you get to a certain point in maths, it stops being about numbers and things that we recognise
Yeah.
at primary school maths, and it starts becoming about all sorts of different things that I have no knowledge of. And he thought, oh, I haven't done anything with circles in like 20 years since I was at school. I can't remember how to do this. But because he is a mathematician, because he's got those skills, as you say, Becky, of being able to reason and think mathematically, and he knows the rules around maths and that sort of knowledge, that sort of disciplinary knowledge around it, or procedural knowledge around it. No, I don't know. Whatever that knowledge is called, whatever the right label for it is, he was able to work out what he needed to do. And we've said before, the sign of a good mathematician, I think, is being able to know what to do when you don't know what to do. How do you get
Yeah.
started with a problem when it's unfamiliar? And I just thought that was a really great example of why we teach maths, because it's not about remembering every part of a circle and being able to recall pi to 100 decimal places. I've got an interesting anecdote about pi, by the way, in a minute. But it is about having those skills, as you say, to be able to solve problems and to get going with things. But if we don't give pupils opportunities to do that, they're never going to be able to do it.
That's it. I think there's only so far you can get with the knowledge, isn't there? I used to love doing maths tests. I know lots of people will be
That's a
like,
very
what?
strange thing to say.
But I always used to think, well, I'll do all the things that I can automatically do, and then I'll have time and I will find a way. I mean, obviously, I didn't always find a way, but that's how I felt about it. It's like, actually, I've got the knowledge somewhere. I could find a way into a problem, and there's not always one
Yeah.
way. It might not be the way they were expecting, but I'll try and get there. That to me is what maths is.
Interestingly, though, by the way, Becky, he did not get a perfect score on the test. So there you go. My my interesting fact comes, by the way, from Tom Isherwood's son. So Tom passed this on to me. He said you might want listeners to know. 6, 7,
Oh,
6, 7 are
yeah.
the 99th and 100th digits of pi. So there you go.
I love
I
that.
don't know what the other 98 are other than the first few, but yeah, 6, 7 are the 99th and 100th digits of pi. I love the fact that he noticed that.
Nice.
So yeah,
Love that.
so
We can
I'm
go
going to be
share that.
doing some more thinking and talking about doing maths rather than watching maths. And hopefully over the course of the next few months, we can talk to some guests as well, and between ourselves, Becky, and come up with some practical strategies that we can use in the classroom to make sure, without trying to add to workload, without trying to rewrite everything, but doing things that are worthwhile, I think, so that pupils are doing maths more often than they are watching maths, I think. And if that's a message that we can get out in 2026, I think that will be a really good thing.
Yeah, sounds great.
Excellent. Okay. So if anybody has got any thoughts on that, please do, as ever, get in touch. Primary Maths Podcast at twinkle.co.uk, twinkle without an E, of course, or send us a direct message on any of the social media platforms. And while you are there, as always, we would love it if you would give us a like, subscribe to the channel, and maybe even leave us a little review, even if it's just clicking all 5 of the stars on your platform of choice. We'd really, really appreciate that. Now, Becky, calculators.
Yes.
Calculators. Not
Yes.
something that we use a lot of in primary schools anymore, I have
Not
to say.
anymore.
When I started teaching, there was a calculator paper in the year six SATs, but that went by the wayside, didn't it? And my daughter was quite surprised when she started secondary school and found that on her list of required equipment was a calculator, because she thought that was something that you just didn't use in maths lessons anymore. Although I have to say, we did have a drawer of them still in my classroom, and we
Yes.
would get them out sometimes just to, check answers and that sort of thing. But it's yeah, certainly something that's less used these days. So, how did you end up going into the backstory behind a calculator?
So, well, it was prompted by your discussion with Dominique from Sums of Anarchy on Tuesday. She mentioned human computers, and I just started thinking about human computers, human calculators, things like that. And so I went, as always, on a journey which encompassed two of our aftermaths favourites actually this week, the history of maths and a bit of etymology as well, to find out a little
Marvelous.
bit more. Now, we could do a whole episode on calculators, John. I have tried to make it as succinct, as succinct as possible.
Strap in, everybody. Get a cup
Yeah,
of tea.
ready.
I've seen the number of pages that this spans to.
So thinking about the first calculators then, of course, are our fingers, really. We talked, I think might have been last week, might have been a couple of weeks ago, about the use of the 10-digit system, and digit, of course, coming from the Latin for fingers and toes, and a method which can still be used successfully today. It's with us all the time, although it has its limitations, doesn't it? I mean, you can
Yeah.
do a certain amount of maths on your fingers, more complex maths, maybe not so much.
I mean, I still use my fingers to do maths on these days. If I'm counting things, I'm trying to keep track of things. Might not
Yeah,
always be single items. We can use our fingers to unitize for things, can't we? And count in multiples and things. But yeah, they're a tool that is always with us, aren't
yeah,
they?
perfect.
Unlike the calculator, which my teacher at school promised would never. I wouldn't always have a calculator in my pocket, and
Ah,
how right they were,
little
Becky.
did they know.
Yeah.
Yes.
I wonder what
Well, we'll
things we
come to
say
that.
as teachers now that kids just, one day they're gonna go, "I can't believe Mr. Cripwell used to say that. Of
Yeah,
course
good
I've"
point.
whatever it is. I don't know.
Yes.
I wonder what that might be.
Yeah, so,
Anyway,
well, how
sorry, calculators.
no, what we will get to, uh, calculators now at the end. We're not quite there yet, sorry. So, the word calculator was first introduced around the late 14th century, and it referred to a person in the same way as a computer referred to a person that computed. It was a person who calculated, coming from the Latin again for calculare, which was to reckon or compute. And I don't think I'd realised that reckon actually was to do with counting. So that was a nice bit of
Mm,
knowledge, new knowledge for me. Um, and the verb calculare came from Latin calculus. And I loved this. Calculus actually was a pebble used as a reckoning counter. So a
okay.
pebble used for counting, which I thought was lovely. And we've done a little bit of Latin, but coming on to ancient Greece, around about 300 BC, it was believed that they used what was called a salamis tablet or a counting board, and it was pebbles that were used to support calculation. So you can see we've sort of moved from fingers to pebbles, which also, pebbles were also believed to be used in the very first abacuses. Abaci, don't know what the plural of abacus is. Abacuses, I'm going to go with that one. Uh, the Sumerian abacus, which dated back to around about 2700 BC. I know these dates, we have to sort of take an average. And those abacuses didn't have like the bars as we would think of as an abacus, but had columns or grooves in. And it was the pebbles were moved in those columns or grooves to represent numerical values. The Sumerian abacus was also based on their base 60 system, one of your favourites, John.
Yep,
Uh,
love a bit of base 60.
yes, because the Babylonians, of course, developed the use of base 60 in time telling, your favourite subject, which was derived from the Sumerians. So there we go. We had to get time in there somewhere, John.
Yeah, good. Excellent.
So, we've talked with abacuses were sort of machines that helped with maths. And I think I was at school in the early 80s, primary school, and we did have an abacus in our classroom. It was a staple. There was an abacus
Well,
there.
they've come back, haven't they, Becky? Reckon Recs are very popular in classrooms now, they're used through mastering number at Key Stage 1
Yep.
and reception quite a lot. So, the abacus, it went away for a little while, but it is very much back. And of course, its near neighbour, the bead string, which also
Yes.
cluttered maths cupboards for a little while, but then has thankfully made a return into the classroom. So, yeah,
Yeah. Love a
this
bead
is
string.
ancient technology.
Yeah. And Reckon Rec, of course, named for reckoning. So maybe I should have known that it was for counting. Anyway,
There you go.
yeah. So then I started thinking about mental maths, moving on from thinking about the human computer discussion with Dominique. Of course, we were probably all familiar with the human computers through the work of people like Katherine Johnson, very heavily involved in the NASA space program. A computer was a person. If you said now to a child, when I grow up, I want to be a computer, they think you'd gone mad. But this was, what people aspired to. And there are people, many people around in recent years and today who have been dubbed human calculators.
Yeah.
So a couple to share.
Never
Shaq
me, Becky. I've
no.
never,
I
no.
mean, when I tell you about these people, I think we'll think never lots of us. But Shakuntala Devi in 1980 calculated the correct product of two 13-digit numbers in 28 seconds.
Wow.
Yes, lots of records held there.
The
And more
product
recently,
the product of two
two
13-digit numbers.
13-digit numbers,
Okay.
quicker than a calculator could. Aryan Shukla, who also holds many world records, can add 10-digit numbers in an average time of 7.8 seconds.
Wow. I wouldn't even have finished reading them in
I
7.8
know.
seconds.
So
That's
some
mad.
people, obviously, you could still describe them as a human calculator. The calculator itself developed massively. So very early on, looking back at like the 1600s, there were calculators built using gears and dials. The Pascaline was developed in
Yeah.
1640. We also have the comptometer, which was built using a macaroni box, staples, and rubber bands in 1884.
That's what I always go for if I haven't got a calculator on me. Just grab my nearest macaroni box, staples, and rubber bands, and I'm away.
A
Yeah.
little
You
bit of
try and stop me adding numbers.
junk modelling there to,
Yep.
to help you build a calculator. And I liked this story, and I
Is
hadn't
it
heard of this before.
did it have to be macaroni? Is there some unique properties of a macaroni box that, like, somebody brought some tagliatelle box and, well, no, no, no,
Didn't
no, no,
work.
no. No, that's never gonna, yeah. Addition works fine with tagliatelle, but not multiplication. You've got to
Yeah,
have macaroni.
not as far as I know, but who knows what macaroni boxes were like
It
back in
just seems a very
1884.
specific form
It
of pasta
is. Yeah.
for calculate. Okay.
Who knows?
Who am I to argue
It's a
with,
question. Yes.
with Curter? That's fine. We'll go with
So
macaroni.
yes, yeah. So the Curter calculator, and this was the pocket calculator. It was developed during by Kurt Herstart during his time in Buchenwald concentration camp during World War
Oh,
II.
wow.
So he was allowed to continue work on it because it was considered important work. Which is, I loved that story. He'd done a lot of work on it ahead of that, but that's when it sort of really became developed. And yeah, as I said, often referred to as the first pocket calculator due to its size, although it looks like a pepper grinder, very different to a calculator as we know and love now. So moving swiftly on to around about 1960, we first saw the first electronic
Which
calculators.
seems not that long ago in my personal timeline as somebody who was born in the 80s. But
Yeah,
that's 66 odd years ago now. But only 20 years after Kurt Herstark developed his pepper grinder type. I just think the 1960s, and 50s and 70s, such a huge progress was made, wasn't there, in these sorts
yeah,
of technologies? Amazing.
that's it. And although the first ones wouldn't have fitted in a pocket, they weren't really pocket calculators. Of course, when the microprocessor was developed and another technological advance, it very quickly they became smaller and pocket-sized. And the first, what was described as a portable calculator, appeared in Japan around about 1970.
Nice.
So that brings us, I mean, it doesn't bring us because that was still a fair amount, a long time ago. But
Yeah.
obviously, calculators over time have shrunk. And now, as you mentioned earlier, they are default part of your smartphone, aren't they? You wouldn't get a phone
Yeah.
now without a calculator or a watch. And you can even calculate from wherever you happen to be through a smart speaker. All I have to do is ask my smart speaker to do a calculation for me. I don't even have to move from my seat or touch any buttons. So who knows, Jon, what people will be talking about as far as calculators go in 10, 20 years' time.
Well, thanks, Becky. That was fascinating, and you're so right. Somebody was saying yesterday at the meeting I was at that um, only a couple of years ago, AI, as we know it as a large language model, AI, chat GPTs, etc., could just about pass a year six SATs paper, and then it became possible that it would get sort of just about a passing grade at GCSE, but now it can do advanced mathematics, and will absolutely ace even an A level paper, which again goes back to why are we teaching maths, doesn't it? And people, I'm sure, would have argued when the pocket calculator came out, why do we still need to teach formal written methods for adding and subtracting and multiplying and dividing? We can just use a calculator. Um, and they're right. If that's all you want to do, then if that's how you see maths, then there is no point, is there, in practicing those skills, because we've all got calculators everywhere, bits of technology that will calculate things for us in the fraction of a time that it would take me
Yeah.
to lay out the question without even beginning to solve it. But that's not why we teach maths. We don't teach maths. We don't teach multiplication, do we? So that a child can do 17 times 346
No.
in a written method. It's a way of, as we've said before, solving problems, understanding the world, and we need to see the structure of those things in order to be able to do it. So uh, technology changes the way that we need maths, but I don't think it changes the fact that we need maths, if that makes sense.
Yeah, it doesn't change what maths is, does it? And like you said, maths isn't just about computational methods. There's so much more to it than that. But again, it's changing the mindset, isn't it, of what maths is? Because I think some people would
Yes.
say that is what maths was, and therefore they could rely on technology to do it for them. It's like the year sevens, isn't it? It's like, oh, get a calculator, it's going to do the maths for me. Well, like any computer, you're going to need to give it what it needs first. So you need to know what
Yes.
information to give it.
Yeah.
But yes, and there were lots of different types of calculators I could have mentioned there, Jon. I just chose a few, but and looking at the pictures online, if you get a chance to go and look at some of them, it's amazing. But that was a quick whistle stop tour of the history of the calculator.
Amazing. And again, I remember at secondary school having to buy a scientific calculator with all those different buttons on it. And I think in my 5 years of Key Stage 3 and Key Stage 4 maths lessons, I think I probably used about 2 of those additional buttons in all that time. I don't remember really understanding what a lot of those buttons did on the scientific calculator, but they looked
Well,
impressive.
even the I was reading an anecdote as I was doing my research around the buttons C and CE and how people don't often know what they are. And I think I'm one of those people. I just always used to press both of them. If I wanted to clear
Well,
everything,
C
just press them
C
both.
just
Press them
clears the last thing
last
that you
thing.
did, didn't it? Whereas CE resets the whole thing. Yeah, I
Yeah.
did know that bit. I just remember having to getting one of those scientific calculators with the cover that you could slide on and off.
Yes.
And some people had the sliding off cover. It slid off, but it had a hinge on it as well, so it then slid back into
Yes.
itself, and that was really posh. And you could write your name or initials on it in Tipex on the front.
Tipex, yes.
That was the best thing about having a
Oh,
calculator. Yeah, Tipex. I bet we don't. Yeah, is that still going? Is that still a thing? But it's not as
I
big
don't
a thing as it
know.
used to be.
I've got an interesting
Um,
fact about Tipex, actually. It's
have
nothing to
you?
do with maths. Well,
Well, that's
this
right.
I
Let's go
could be
for it.
telling a lie, though. You might have to edit this out.
At this point, Becky, it's a tenuous link to maths on this show anyway,
You
so don't worry about it.
you might have to edit it out, Jon, if it's not
Okay.
correct. But I think that Tipex might have been invented by the mum of one of the monkeys, the 60s band, the
Ri
Monkeys.
As in, hey, hey, we're the monkeys. That,
That's
yeah.
correct.
Well, I can tell you, Becky, that is true. So Betty Neesmith Graham, the mother of Michael Neesmith,
Mike, yes.
who was the guitarist and singer, invented the first widely used typewriter correction fluid. If you're not familiar with what Tipex was, how are you listening to this podcast? You're far too young, clearly. But it was it's sort of a white paint almost, isn't it? That you painted onto
Yeah.
if you made a mistake, whether you were writing in pencil, in pen, or on a typewriter, you could paint it onto the page, and it would then you could go over it with the correct way. But more widely used, I think, for writing people's names and initials on the
Yes,
fronts of scientific calculators at secondary school. That was really where it found its niche, I think.
definitely.
Um, so there you go. Thank you for that, Becky. I enjoyed that. If anybody's got any calculator-based stories, we would love to hear them, or stories about things invented by members of bands' parents. That would be lovely as well. Thank you very much.
Good luck finding some of those.
Yeah. Who did, I want to know what Kylie Minogue's mum invented. That's where I want to go next, really.
Maybe
Um,
someone will write in and let us know.
yeah, yeah. Okay, right. Research in six. Let's pull this back towards maths a little bit. Okay. Research in 60 seconds ish. Okay. Are
Okay,
we ready? You got a
we are
timer going
ready.
for me, Becky? Okay.
Yeah.
I'm going to get it this week. Right. You count me down and we'll go.
3, 2, 1, go.
Okay, so this week's study was published in 2026 by Anne Dowder, and it was a comprehensive literature review of maths anxiety research with particular focus on age, gender, and culture. So, essentially, what it found was it's a vicious cycle. Maths anxiety isn't just a dislike of the subject, as we know, as we've talked about on this show. It's a specific emotional tension that eats up working memory, leaving less brain power available to actually solve problems. So you're spending too much energy worrying about it, not enough energy to actually be able to solve the problems. And this creates a reciprocal relationship where anxiety lowers performance and poor performance fuels more anxiety, and therefore pupils get trapped and adults in a vicious circle. Now, what this was looking at was who was most effective, and they found that age mattered. So anxiety typically spikes as children move from primary to secondary school. So there is something about that transition,
Mhm.
maybe something about how maths lessons change or setting or streaming. I don't know. That's my conjecture, but certainly something to bear in mind. But that has an effect. It could just be the age rather than the movement. I don't know. It didn't go into that, but still, there is a gender gap. Females consistently report higher maths anxiety. However, the research shows their actual performance is usually equal to the boys. And the anxiety stems from social stereotypes and confidence issues, not a lack of ability, which is exactly what Emma Lockhart was saying on this podcast 3 or 4 weeks ago. Go back and have a listen to that episode if you haven't and you want to know a little bit more about that. In terms of culture, you might assume that high performing countries are confident, but the opposite is often true. Nations at the top of the international league tables, like Japan and South Korea, frequently report the highest levels of student anxiety. The research points to a surprisingly simple intervention, which is expressive writing. Having pupils write down their worries before a test seems to disrupt negative ruminations, frees up working memory, and significantly boosts test scores. So, SAT's coming up in just a few months. We've talked about this. We did an episode on SAT's prep. Maybe one of the things that we need to do as part of SAT's prep is explore what students are worried about, what pupils are worried about, get them to write those things down before the test, and maybe rationalize them a little bit. And that apparently has been shown to free up working memory and improve their test scores. So there you go. I thought that was quite interesting, Becky.
Yeah, that was good. And a nice little takeaway there for people to try. I like the idea of that, actually getting out everything out of your head before you
Yeah.
start the test to try to free up a
Yeah.
little bit of memory.
Well, that's
You
what I do
yeah,
when I'm
just
feeling overwhelmed with stuff. I have to write down a list of everything that I need to do and things, and that does help me a little bit.
yeah, no, that's good. And you did it in just less than 3 minutes, John. So well done.
It's getting quicker. Yeah. We will have to just relabel the whole thing at some point.
That's
Maths in
fine.
180-ish seconds, but there you go.
No, I mean, really interesting. And interestingly, it backs up a lot of the things that we've talked about. We mention maths anxiety quite often, don't we? And it feels
Yeah.
like we, yeah. got a fairly good understanding of what's going on there. Interesting though, the cultural thing was interesting. I think I would have thought it was the other way. So
Yeah,
thank you for
to be
sharing.
fair, Heidi Kirkland, in our first ever episode, Becky, mentioned this, that she wasn't necessarily talking about countries and jurisdictions, but she was talking about pupils who perform most highly. You would think that they wouldn't suffer with maths anxiety, but actually the research and the evidence shows that they do. So there is a strong link there between, um, you know, uh, expectations, I think, as much as anything. And I think that the gender divide backs that up as well, because as
Yeah,
it as the study showed, there wasn't a gap in ability, but there was a gap in how much anxiety was felt around the subject. So it's not an ability thing. We know it's not an ability thing. Obviously, it can be, but it isn't.
not necessarily.
Solely. Yeah, it's not solely an ability thing. So that's useful to know. I think useful to be able to bear in mind, and what I liked about it was that there was a practical takeaway in terms of what we could do to help pupils ahead of things like summative assessments, like the SATs.
Yeah, that was really useful.
In terms of takeaways, Becky, we are moving away from discussing the takeaways in this Aftermaths podcast, are we not?
We are, yes. We often have quite a lot to talk about from the previous episode, and it feels like repeating a lot of the things from that episode is taking up space where we can talk about other things. So I think you've got another idea for how to share our takeaways, John.
Yep, we're not getting rid of them entirely because we know people do find them useful. But what we're going to do instead is we're going to have Jon and Becky's Friday night takeaway. So you will be able to find the takeaways on social media, on Instagram, on LinkedIn in particular, um, on a Friday each week. So give us a follow on LinkedIn, give us a follow on Instagram. On Instagram, it's John Cripwell Maths. On LinkedIn, you can find me, John Cripwell. There's not many John Cripwells, John without a H in it, because I'm Jonathan, really, but only if I am in serious trouble with my mum. Or you can find Becky Brown. There's a few more Becky Browns on LinkedIn than there are
Yeah.
John Cripwells. Hey, that could be an episode, Becky. We'll look into the numbers in a Dave Gorman type way. How many different Becky Browns can we connect
Yes.
with around the world? Um,
Oh dear.
but yeah, you can certainly find us on there. Obviously, we both work at Twinkle, so that could be a way to find us as well. But we will post them on there each week for you to find and use at school should you need to.
Yeah. So that brings us to the end of today's episode. Thank you for listening.
We've enjoyed having you along. We've enjoyed learning about calculators, maths anxiety, and watching versus doing maths. So lots to think about ahead of next week's episode. I will be back on Tuesday with an interview with Joe Austin, where we are talking about how to choose the best manipulative or the best representation for the maths that you are doing. So look out for that one. It's a really good interview, and you'll be able to access that on Tuesday morning.
Looking forward to that one, John. Thank you for joining us today. Just a reminder to give us a quick rating or review, as it really does help new listeners to find us. And we'll see you next time.
Yep. Thank you very much. Have a good weekend. We'll see you then. Bye.
Bye.